Welcome everybody. This is Designing Event-Driven Integrations using Amazon EventBridge. My name's Stephen Leedig. I'm a Principal Serverless Specialist Solutions Architect with AWS. Say that really quickly 10 times, it's a bit of a mouthful. Today, what we're going to be talking about is what it fundamentally means to design an event-driven architecture using EventBridge. I'm going to make some assumptions around your knowledge of what EventBridge service is. I'm going to assume that you already know features like event buses and rules and targets and features like the schema registry. Today's presentation is largely about an exploration of what it means to use the serverless event bus as a core component of your integration strategy. I want to talk to you about some of the, common themes that come up when I talk to customers about event-driven approaches to integration, as well as some of the key design decisions that need to be made as you plan for organizational-wide adoption. This means having a core understanding of concepts such as coupling in a distributed system. It means understanding how to use the right events for the architecture at hand. It also means understanding the roles and responsibilities that producers and consumers have and how that relates to EventBridge. And finally, I want to share with you some of the thoughts that I think are important when you consider using EventBridge and designing for a serverless integration using EventBridge. So in many ways, this presentation is about all of the things that I didn't get to speak to you about in my 2020 presentation on a very similar topic where I explored, amongst other things, core themes and concepts around event bus topologies. If you haven't seen this presentation, don't worry. You can catch this on our YouTube channels. But effectively, what we try to help customers understand is to answer these questions. Do I use a single event bus in a single account? What about multiple event buses in a single account? Do I use a single bus across multiple accounts? Do multiple event buses across multiple accounts? Now, two of the most popular approaches today with customers are the multi-account topologies, and there's good reasons for that. Customers today like to have an account per service account per service strategy because it provides those applications with a blast radius. It also adds an additional security boundary to those applications, as well as allows customers to easily track individual service costs. Well, probably one of the most popular, or the one that the pattern that, or the topology that most customers start with as they look to adopt EventBridge is the single bus multi-account pattern. And this is characterized by event producers all publishing events to a single central event bus. It also means that all of the subscribers to those events are also putting rules onto that same event bus. Now, this resource isn't typically owned by any one team. There's typically a DevOps team or an integration team or a platform team that's responsible for managing the policies on those event buses, as well as working with the respective service teams to make sure that they have their resource needs met. The multi-bus, multi-account topology, on the other hand, is characterized by services publishing events to an event bus that they own as part of their own application stack. And the only rules that they have on those event buses are the rules that subscribers that are interested in receiving or consuming those events the only people consuming those events are interested on putting rules onto that event bus. Sorry, it came out a bit wrong. And here the application team itself manages the actual resource itself. And they create and provide all the policies that allow subscribers to events to place rules on the event bus by features such as resource policies. Now, this does mean that those rules are typically more distributed across your environments and can potentially add some operational overhead. But as we'll see, this is actually not as bad as you might think. So let's remove some of the noise and take a look at some of the similarities and differences between single bus and multi-bus cross-account topologies. And one of the things that I've had the chance to think about a lot in the last couple of years is really the distribution of resources in these topologies. Now, the first observation I want to make, which might be fairly obvious, is that a single bus does not mean just one bus. You need to have multiple event buses today to be able to send events from one account to another. And when you think about it, this is actually not a bad pattern, because it allows you to separate the routing logic from the way that you integrate applications on the receiver's end. You can add and you can remove integrations without affecting how the events are, how you receive events in the first place. Now, the other observation is around the perception of the number of resources that you need to manage. Now, I've heard arguments over the last couple of years that managing a centralized or a single bus topology is easier than a distributed one. But I'm not really sure that that's true. I mean, it's true that resources are a little bit more distributed, but I would argue that there isn't much in the way of the number of resources that you need to manage. It's certainly not reflected in this diagram, where we can see that with a centralized or a single bus topology, you need to have at least one extra team and one extra event bus to manage, and that's a bit of an eye-opener. Now, the way to think about this really is in the terms of ownership, though, right? How are your teams structured? How do you want to delegate responsibility to teams across your organisation and to manage the resources? And the other thing worth mentioning here is that, at least with this multi-bus or decentralised topology, development teams have the means or they own the means to distribute events for the applications that they're building, all right? And this, to me, seems like a very natural way to want to build applications, because it makes those applications much more portable when you don't have dependencies on other sort of centralized or shared resources. Now, but the most important distinction I think to make here is, is the distinctions between these topologies is the distribution of rules. There's these subscription rules, as I like to call them, which are created by consumers for particular events that contain the rules and the patterns and the potential transformations that they have, and manage the targets that deliver messages to the receiving account. And there's the integration rules that are created on the event bus that the receiver uses to integrate and to applications that are processing those events. As you can see here, that this isolation of security boundaries is also a good thing from that perspective, because it means you don't have to have multiple cross-account topologies in your environment, which makes it, and everything is isolated to the consumer's account, which makes managing those resources a little bit more easy. Now, in a single bus topology, all of the subscriptions are on a single bus. Now, that's actually not a bad thing, because you can actually look at an event bus, and we'll look at some strategies later on around how to make this easier, but you could look at the number of rules on your event bus and you've got everything in one place. Well, with a distributed application, the rules that are more aligned to the behaviours or the relationships that producers and consumers establish between themselves, which also has some benefits, because it allows those producers to view all of the subscriptions or all the applications that are subscribing to events that they're publishing without having to have a delegated access or special access or permissions to view resources on a central event bus that they may not have permissions to access. So it's worth considering. Now, rules aren't the only thing that are distributed across your event buses. The other thing that's important to sort of take into consideration is that event bus also have limits on the number of rules that you can have on each bus. And so with a centralized event bus in particular, one of the things that we need to be aware of is that you've got every single subscriber or every single service putting subscriptions onto your centralized event bus, then you could potentially run out of limits pretty soon. In contrast, with a multi-bus approach, the rules are distributed according to the relationships that publishers have with consumers, and also, therefore, managing those limits is also a little bit easier. But what do you do if you have a situation where you have adopted a centralized topology and then you do run, or you're coming close to running out of space? Well, one solution might be to add another centralized event bus into that account, and then look at providing some logical grouping and assigning publishers to either one or the other bus. That then also has the effect of distributing rules across multiple event buses. Well, we need to be aware of that and work with our other services that are creating rules on those event buses to make sure that they have the appropriate policies to do that. And they also need to be aware of where certain events are being published to. Now, this is one way you could potentially do this, but it allows you to maintain that centralized topology that you've adopted in your organization. So which one's better? Well, it depends. Now, I know that sounds like your classic architecture kind of answer to everything, right? But really, it really all depends on how you want to structure your teams and how you want to manage resources in your organization, like I said earlier. And there's nothing actually stopping you from adopting one type of topology and then evolving that to adopt another type of topology. Because fundamentally, we need to bear in mind that there's actually a lot that you can do with a single line of code. We're not talking about a messaging middleware that the only way they scale that middleware is up. You don't need to hire specialists with technical knowledge around how to implement proprietary tools and protocols. What you get with Amazon EventBridge is a highly scalable serverless solutions that can be used and adapted to any type of topology that you want to adopt within your organization. And you can process events, tens of thousands of events per second, and you can distribute those globally. And that's a pretty powerful concept. By moving applications to the cloud, or building cloud-native applications, fundamentally means that we're going to be working in a distributed architecture. And this means thinking differently about a lot of things, such as how we manage dependencies and encapsulation and things like coupling. Now, if you're like me, one of the things that has always been constantly hammered home to you as a software developer is that you've got to have loose coupling and tight cohesion. Well, when you look into this a little bit more, you start to realize that there are multiple facets of coupling that you need to be aware of, and when we're designing our systems. And ultimately, we need to appreciate that coupling is a function of multiple dimensions, and there is no such thing as loose or tight coupling. It's a matter of making the appropriate trade-offs within our applications, and like Gregor Hoppe says, it's dependent on the level of coupling control that you have over your endpoints. But not all coupling is bad. Having no coupling at all is just as bad as having lots of it. If you've got no coupling in your systems, you're not interacting with anything and nothing is interacting with you, and that's not particularly useful for business. Now, this leads me on to a quick but important discussion around events. Now, in almost every presentation I've delivered on EventBridge and event-driven architectures, I've included this slide with this definition. An event is a signal that a system state has changed. And while this is technically true, it's actually more than that. An event is an immutable object. Now, this is often an overlooked characteristic of events. Yes, if you're in a situation where you find yourself wanting to modify an event before it's being distributed to subscribers of an event, then potentially you're not implementing an event-driven architecture. You might be looking at implementing a sequence of events that transform a message in a more of a point-to-point way, but you're certainly not doing event-driven. Immutability is a fundamental characteristic of pub/sub architectures, and one that needs to be respected. But the definition that resonates with me the most is this one. An event is a contract for integrating system boundaries. Now, thinking about events in this way actually means that we're not just dealing with the technical implementation of our integrations. We understand that we're dealing with business-level relationships that are established on the basis of making commitments to contracting parties, and that there's an inherent level of trust between an event producer and an event consumer. Now, like coupling, events come in different shapes and sizes. Now, a lot of the time when I hear people talking about events, there's not really much of a distinction made between one event type or another. And I fall into this trap myself all the time. But understanding the different types of events will really help us understand where and when to use them and how to apply them to our architectures. And Martin Fowler actually has three definitions for event types that are really useful ones. So the first one is the notification event, which is really about that signal that I just talked about. Now, generally, these events are, they notify us that something important has happened, but are generally void of information and context. And anyone subscribing to those events would typically have to query another system in order to get more information about potentially what to do with it or how to process those things. The event-carried state transfer event is fundamentally an event type that we consume when we want to capture changes in information. Now, think about the events that are emitted by, say, a DynamoDB stream. These events effectively represent a change in and represent a delta of items in our tables that have changed. And these are actually really useful types of events for distributing local state across a number of different services, so those services can maintain a local copy of that data without having to query an external or the source of that information for additional information when they want to process events or execute business processes that they're implementing. Now, the domain event is really a combination of the both. Right? With the express difference that it's intended to be self-contained. And it's modeled as close to our domains as possible and includes all of the context necessary for consumers to be able to process that information without having to query an additional source. Now, the event that most closely aligns with EventBridge is the domain event. Now, its structure allows producers to add context to the events that they're publishing. Now, uniformly describing events in this way is fundamental to integrating our systems. Now, irrespective of the type of system that's created this event, it could be an application that you're building, it could be an event that you're consuming from a third party, or it could be an AWS service event. They're all represented in the same way and can therefore be handled in the same way. So understanding the roles, understanding who owns what in EventBridge is also something that I help customers understand. So let's dive a little bit deeper into some of these roles and responsibilities and how that pertains to resource ownership that we discussed earlier. So in publish-subscribe architectures, that's effectively what we're trying to implement with EventBridge. And in this pattern, the event is the primary means of integration. Now, you could have multiple logical publishers on an event that may or may not be executing and publishing events across different execution environments, but logically, they're all the same event. And you can have one or more event consumers. And in this architecture, there's no point-to-point connections between system boundaries. And this helps us address the multiple forms of coupling that we saw earlier. But we don't want to remove all the coupling. The good coupling, the stuff that supports our business interactions across system boundaries, really what we want to try and promote. Now, by subscribing to a particular event, we establish a contract between event producer and event consumer. These contracts can be formally established through things like EventBridge schemas. These specifications describe the structure of the event and can be used to discover and validate and share events across our organization. And as I'll show you later, we've got customers and open source community contributions that are using schemas in very interesting ways. Now, producers should care about who they enter a contract with. There needs to be some kind of a business justification for an application to consume an event in the first place. After all, it costs money to build an integration. So producers should therefore also think about putting some controls around who can consume those events. And we'll talk about why that's important a little bit later. Now, with a contract established, what then are the producer's responsibilities? Well, fundamentally, a producer makes a commitment to publish what they say they are going to publish. Any deviation from that violates the contract. Now, this includes ensuring that even as the event structure changes, that there is consistency across system boundaries. Now, once an event is defined, it typically won't change very often. But if it does change, then a new contract needs to be established, which also then means that consumers need to provide new implementations for those events or update their existing subscriptions. This also means that for a period of time, while this transition is happening, that producers may need to publish two versions of the same event at the same time to support consumers or onboarding new events, while at the same time providing some backwards compatibility for producers who still haven't implemented version 2 of that event. But ultimately, publishing multiple events isn't a sustainable activity for producers. And because it adds additional complexities to the solution. But knowing who is subscribing to a particular event and what version of event that they're subscribing to will help those producers understand who they need to reach out to try and get them onto the newer version of the event with the view of decommissioning the older event. Fundamentally, you can't have two versions of the same event existing in the same space at the same time. Well, finally, it's the producer's responsibility to ensure that they send events as close to real time as possible without consideration of who or how those events are being processed. Now onto what producers are not responsible for. Producers make no assumptions around how events are being consumed or whether they're being consumed at all. As I just mentioned, a consumer may be interested in who is subscribing to a particular event or in a particular version of the event from a perspective of understanding of what impact they may have on the rest of the system if they make changes to the contracts. But taking into consideration the needs of the consumer, any needs the consumer has, such as like their rate at which they can process events or things like transformation, introduces a level of coupling that we're trying to avoid in the first place. Now, these considerations are really the responsibility of the consumer. The consumers determine how the events that they're subscribing to should be routed and consumed. And they need to make the appropriate decisions to make sure that they can consume events at a rate that is suitable to them. And that means making sure that there's sufficient scale, or introduce a buffer such as Amazon SQSQ to rate control the event ingestion. Equally, any transformation needs that a consumer has are their responsibility, because those needs are very specific to the application that is consuming those events. And these are not things producers should be concerning themselves with. So now, how do we map these responsibilities of event producers and consumers to EventBridge service capabilities? Well, this may vary slightly depending on the type of topology that you choose to implement and who owns the event bus. But fundamentally, most of the responsibilities that a producer has happen even before an event is sent. Mainly, ensuring the integrity of the event itself. Now, one of the first things that needs to happen in this relationship is setting up the appropriate permissions on event bus that allows producers to send events to the event bus itself. If you own the event bus, then this is a relatively straightforward exercise. But you also want to ensure that nobody else can publish events to those event buses. The event producers also own the schema. They own the event definition, therefore they own the schema that describes the event, and also own the event schema, the schema registry that stores and publishes that event to the rest of the organisation, including who can access and use those schemas. In order to maintain a decoupled relationship, event consumers should essentially be able to create rules on an event bus that they don't potentially own. All right? Event producers should be able to add and remove rules on event consumers should be able to add and remove rules from an event bus as their needs, as they see fit. And they should be able to, that includes also defining all of the patterns, all of the integrations, and things like dead letter queues and retry policies. Now, for this to actually happen, the event producer needs to grant the necessary permissions to allow event consumers to be able to do that. And that's what I was saying before. Producers should care about who's subscribing to a particular type of event because it's relevant to the way that they implement security policies. Now, an exception to this rule is potentially API destinations. While external APIs technically own all of the own the endpoints, including all of the credentials that manage those endpoints. But because we don't actually have a way for us to delegate responsibility to external parties to be able to create resources on an event bus, it's something that needs to be the event bus owner needs to take responsibility of and work in conjunction with those external API owners to make sure that that integration stays current as their security credentials potentially or endpoint configurations change. So now that we have a clearer understanding of who owns what, let's take a look start to think about putting all of this together to design an event bus that forms a central part of your integration strategy. Now, when I was thinking about how to best, put all these and communicate all of my ideas around what I thought was important to consider when we are designing our event-driven integrations, I started putting together this mind map. And I thought, this is actually a really good way to communicate those ideas to you, and that's why I'm going to be sharing this format with you today. So in our discussions so far, we've largely been talking about producers and consumers, but there's also other things that are really important to consider, such as the events themselves, which really form the heart of our integrations. Governance is also a critical part of building an event-driven integration, as well as the evolving concept of discovery. So let's take a look at each of these in turn and dive into some of the specifics along the way. Now, as I said, events are at the heart of integration, and putting some structure around your events is really fundamental to the way that you manage your integrations. The key to doing this, I think, is to consider putting together a conventional approach to naming. Now, I know that sounds very simple, but when you think about fields such as the source and the detail type, they're really important parts of uniquely identifying an event as that flows through your architectures. And you should be able to look at these fields and be able to determine and uniquely identify where the event came from and what its intent is, without actually even looking at the data or the detail that that event has. So think about these fields as almost like a composite key, right? So even if you have fields that have a similar detail type or have the same detail type, you still have the source field that uniquely identifies the domain from which that event originated to help clarify the context of that event. Now, you're probably thinking to yourself, why go to all this trouble, right? Why not just let all of our teams loose and let them call events whatever they want to call them? But think about where all of these events actually, where you might actually find these fields. Particularly around things like observability. You're likely going to be tracing, you're going to be logging, you're going to be potentially looking at, you're going to be troubleshooting your events and potentially putting some security boundaries around your events as well. So having some consistency around how things are named is really going to operationally make your life a lot easier. Now, another thing to consider when designing your events, and this is what companies like Lego and PostNL have been doing, is thinking about how to extend the context of the event itself. And this includes adding things like a dedicated metadata field that sits along the event detail. Now, this is really useful for adding fields such as immutable event IDs. You might want to put some information around, where that geographically where that event originated from. If you have a globally distributed architecture, you might want to be thinking about, putting in information around what order the event has in a particular sequence of events, things like this. But bear in mind that as you think about designing your metadata field, that this fundamentally will form part of an extension to the EventBridge envelope. And so having some stability and consistency around how that's defined is really, really important. Now, producers also need to enforce the integrity of the events that they're publishing, all right? And this also makes sure that if you are adding metadata objects to your payloads, that is enforced and that happens consistently. Like I said, defining that metadata field and making it a consistent, stable object is really important. But it is also equally important to make sure that you implement that consistently. And sometimes the challenge with this is, how do you do this, right? You can't just rely on your development teams to do the right thing. Most of the times, we need to know how to, you're asking those development teams to add and understand for each and every event that they send, how to implement this logic and how to add that metadata field on top of all of the other contextual information that they're actually sending as part of the event detail. So this is where you might want to think about, creating reusable libraries and utilities that share or that you can share across your development teams that take away some of the responsibility from them even knowing how to create those metadata objects in the first place. And this may also include abstracting the fact that you're using the EventBridge SDK altogether. Now, one of the key activities that integration teams could be doing is actually looking at supporting this type of utility and sharing that across the organisation, potentially even distributing those across the organisation through things like private package repositories. So let's take a look at it as an example of how this might be achieved. Now, in this example here, I've written in C#, we've got a customer-made preferred event, which is a very simple event that has a customer's ID, and it also has the date and time that represents when the customer became a preferred customer. Now, note that this does not have any metadata fields attached to it or defined. Now, to model the metadata in each and every event in our domain doesn't make a huge amount of practical sense. And it doesn't actually reflect the domain that we're building. All right? This is more of an integration requirement that's not really in any way associated with the domains that we're modeling. So let's not do this. What we want to do is look at ways that we can inject this metadata property before we actually send the event. And that means creating a utility that effectively provides some type of interface, such as I have here. And in this case, the utility library defines a generic interface called iPubliched that takes an event class along with some data that represents the source and detail type and potentially the event bus that I'm sending it to. Now, you could actually take all this stuff out and you could actually use application configuration to provide these fields, but I actually left this in here just to make a point and to demonstrate and leave it in there for clarity. Now, the detail and metadata classes that you see in front of you here represent the JSON objects that will get sent along in the detail field of our put events API call that we make to EventBridge. Now, when a new detail field object is created, the event that we want to publish is assigned to the data property. And the metadata property is automatically initialized with an event ID, the event time, and in this case, our location property. Now, with these classes and interfaces defined, the caller then simply needs to create a new customer-made preferred event and send that to the utility library via the publish event method. This implementation then abstracts the EventBridge SDK and takes care of creating the required detail property with our event data and the metadata. So having your own kind of messaging utilities really opens up some kind of a whole wide range of possibilities. You could further extend this implementation and create libraries that not only look at dealing with metadata, but also how to do schema validation before you send an event, around implementing durable publishers that in the event that you are unable to publish an event, that you are durably persisting and then potentially creating your own retry policies. Because after all, once an event is published, it just doesn't disappear. We want to maintain consistency in an environment, make sure we publish every event. And we also need to make sure that we're validating potentially things like naming conventions and making sure that the events that we publish meets the constraints around message size that EventBridge has. Now, another area of particular interest with customers over the last couple of years is how to deal with sensitive information in events. Now, obviously, this requires us to protect the information, and it's not just at an infrastructure level. Now, EventBridge is already providing you with in-transit protection. We're also protecting all of your data at rest. So this requires a different type of solution. The question comes then, well, how is this going to work? All right? Is this something that we have to delegate to our middleware? Is this the responsibility of another service? It seems to me that the obvious choice here is to use client-side encryption. All right? Now, you don't want to encrypt everything. Right? If you encrypt the entire payload or the detail of the information that you want to send, then you're potentially stopping subscribers from routing on fields that are in those events. So it's up to the publisher to make sure that they are encrypting sensitive fields, or the field values that they're sending in that event, while still maintaining or giving consumers the possibility to route and potentially identify which events they want to consume from the fields in the payload. Now, like I said earlier, publishers should care about who they establish a contract with. And this is a really good example of how encryption keys form an extension of that contract. Now, using services like KMS allows us to, to control access to keys that we use as part of the encryption, and that we're sharing then with subscribers. So only those subscribers who've got access to the key can decrypt the information that's in those payloads. Now, one thing to be aware of, once that event is being consumed, the event consumer might want to persist that information or retransmit that information through another event, and then they need to use their own key. They cannot use the key that the publisher or from the publisher that they consume the event from. But before you do this, I would ask myself, why? And for a very simple reason, because we're not just sharing events across potentially sensitive data across potentially multiple domains, right? We're fundamentally transferring ownership and responsibility of that sensitive information. And this action in itself can potentially, violate some, in some countries, violate some compliance laws. At the very least, it diminishes the safety of the information. Because the more services that are responsible, involved in safeguarding this information, the harder it becomes to monitor and to audit. So my advice would be take another look at whether or not you want to actually transmit that personally identifiable information in your events in the first place. And look at how you've modeled your domain and why they need that information. Okay, let's move on to consumers. Now, like I said, naming conventions play a really important part in, and are really useful for defining and modeling our events. And the same is true for rule names that consumers put on an event bus. Now, again, consistency is key here, right? Coming up with some conventions around rule names will make managing those rules a lot easier. Now, event consumers today need to be aware that rule names on event buses need to be unique. It's not unreasonable, though, to expect event consumers to be able to define rules according to their own domains. So the fact that those rule names need to be unique also puts a bit of a burden then on potentially on those consumers, and it forces them to identify whether or not another name has been created on the event bus that's potentially could introduce some conflict when they're creating those rules on the event bus. But this is not something that you want to be really worrying about. Now you could try and manage this with with tags and stuff like that, but unfortunately those features aren't supported with CloudFormation yet. So, as I said before, the solution here lies in, organisational standards around rule naming. And one approach that you could take is, defining a convention that incorporates who is subscribing to the event, how that event is integrated, and also, that has some details around the type of event that is being consumed. And this has the effect of making this approach establishes a kind of uniqueness within your architectures, because you're basing those naming conventions on the source and detail type, which, as I said before, form a kind of composite key, thus making it unique. Now, bear in mind that just because the events need to be unique on an event bus, this is probably something that you should do anyway, as a good practice. Now, probably one of the most challenging things, challenging responsibilities consumers face today is how to process events only once. Now, because we're communicating in a distributed system, we're subject to things like the CAP theorem, where we're fundamentally making decisions around consistency and availability and the effect that partition tolerance has on the version of truth that either side of that a system on either side of the partition has. Now, in the event where we do get a partition, such as potential network failure, for example, an event is sent to a target. It's processed successfully by that target, but the acknowledgement or the response is never received by the producer. Now, the producer is likely to want to retry the delivery of the event and resend the message, and causing the consumer to potentially process that message twice. And this can have unintended consequences on a consumer side. Therefore, we need to have consumers built with idempotency in mind. Now, idempotency fundamentally means that a consumer can receive an event twice and process and have the same outcome without any side effects of duplicate processing. Now, there are a couple of strategies for dealing with idempotency, but one popular way is to implement and define an idempotency key. Now, in this example, we could use the event ID that we set in our metadata object that we created earlier. Now, this provides us a way to track the idempotency state in an external data store. Now, what I'm showing you here is a diagram of the idempotency utility for a utility that we've created called AWS Lambda Power Tools for Python. Now, the function, so in this implementation, an event is processed by a Lambda function, which includes the idempotency key. The utility records the fact that it's receiving an event with an idempotency key, stores that, registers that in an external data store, processes the event, and then makes sure that the response is persisted before a response is sent. Now, in the event that the response is not received by the actual producer, the producer is likely to resend the event with the same idempotency key. And the utility checks the data store to see whether or not the idempotency key exists and returns the result without having to do any further processing. There's also there's lots of resources around how to implement idempotency, and there's a really good one called Making Retries Safe with idempotency APIs that's available in the AWS Builders library. And this shares insights from the AWS engineering teams of how to deal with idempotency, which I highly recommend you take a look at. Now, the other important aspect of managing state is determining the length of time that idempotency is evaluated. Now, for example, you could look at Amazon SQS and Amazon FIFO, SNS FIFO implementations, and you'll see that there's a deduplication window of 5 minutes. Now, setting this time is really about finding the sweet spot between a time frame that constitutes uniqueness as well as the performance of your system. And you want to make sure, and you may want to consider more or less time depending on your particular use case. Now, from an EventBridge perspective, we need to understand that the idempotency windows plays a really important part, depending on the type of use case that you're currently looking at. Now, if you're doing a runtime implementation of idempotency, then using a feature like AWS Power Tools is an adequate solution. But what about if you are looking at retrying failed delivery of events? There, the idempotency window may be greater than 5 minutes. Equally, if you're retrying or redelivering events from archive and replay feature, you also have a much larger window that you need to deal with. So think about strategies that you might want to implement to help with the deduplication of events, deduplication of processing events. Now, generally speaking, it's probably best to assume that you're going to be processing events more than once. We need to be aware of the fact that partitions don't just occur on the network, right? They can occur on disk, they can occur in the database. There are many different places where partitions can manifest themselves. And dealing with idempotency requires significant engineering effort. And it would really focus on making sure that you only implement these solutions in the critical parts of your system. Because sometimes it's actually just easier to deal with duplicate records. But if you're in doubt, check with the business, right? Because probably they've been dealing with idempotency or duplicate processing long before there was a technology solution for it. Now, governance is also a big part of your event-driven integration, and there's a lot more to this than I've been able to brain dump here today. But here are a few key takeaways. Now, observability is a key to operational success, irrespective of the type of architecture that you're building. Now, we've published a lot of information around articles and documentation on serverless observability. We've also created the serverless lens, which is part of the well-architected review, which I also encourage you to look at. And now with AWS Lambda Power Tools that we've written to make it easy to take those best practices from the serverless lens and embed them, so you're implementing best practices for things like logging, metrics, and also traceability in multiple runtimes. And as I've said before, there's a lot of value in reusability like this, right? So you can implement consistency and conventions across your organization while taking away some of the complexity involved in implementing this from your development teams. Now, with X-ray support for EventBridge, you can also start to begin to trace events as they flow through your system, providing you with further insights into the health of those architectures. And using services like AWS CloudTrail, you can also build automation around enforcing the rules and standards that you've established within your organization. Now, there's a lot of discussion today around event discovery, cataloging, and describing events for consumption across the organizations. Your organizations. And some of these capabilities already exist in EventBridge via schemas and the schema registries. Now, I've spoken at length around the importance of schemas in establishing integration contracts between system boundaries. They not only help us understand the structure of events, but they also play a big part in helping us understand the relationships that applications have with one another, and through versioning, help us more easily identify what those dependencies are. Now, there's still a lot to do in this space, but one core capability that we want to develop is this whole idea of sustaining and building real-time flow of information across system boundaries, and doing so through self-service mechanisms. Now, we're now seeing AWS community builders and open source tooling built on EventBridge to help us achieve these things. Now, one such example is an open source project by our developer advocate called David Boyne, called Event Catalog. And now, once deployed, this tool transforms your schemas, your rules, and your targets into documentation. And it provides an extensibility to further annotate your events, your event catalog with code samples, and also help provide visual representation around how events connected, mapping producers to consumers. Now, these are really powerful features that help us teams better understand the makeup of your architectures, as well as communicate architectures internally to other teams. So I recommend you check this out, and thanks to David and all the other community builders who continue to contribute to this space. Now, this is where my mind map journey ends for today. There's still a lot to think about, and I hope this has provided you with some guidance around, and better understanding around how to use EventBridge as a core component of your serverless event-driven integrations. I want to leave you with a few key takeaways of this session. So there are many different aspects of EventBridge, and understanding the importance of the roles and responsibilities that event producers and consumers have is really fundamental to working with EventBridge. You need to think about how to maybe take away some of the heavy lifting and build custom libraries or use AWS Power Tool libraries to help make life easier for developers, that help them be more productive and take away some of the complexities in dealing with programming challenges such as publishing events and idempotency. And look to conventions to better manage some of your resources and deal with automation and observability. And continue to challenge yourself and to challenge us around how to build better, more sustainable event-driven capabilities through features like discovery that help you going to build your event-driven architectures in the future. I'm going to leave you here with some additional resources as well. This is just a mere snapshot of what's available today. If you have any further questions, please feel free to reach out to AWS teams and reach out to our growing community of serverless developers as well. And to continue your serverless learning, we have a wide range of learning resources that I'd also encourage you to look at. And I'll just leave this open for a couple of minutes. And, well, this is probably no longer relevant, but if you want to take a snapshot, these are some great presentations that have been delivered through the course of this week, and once they are available on our YouTube channels, I highly encourage you to check these out. And with that, I want to thank you very much for coming. Enjoy this evening, and look forward to speaking to you again. Thank you.